As you look up into the immense expanse of space and observe the mesmerizing shimmer of countless stars, a timeless question begins to emerge, one that humanity has asked for generations. Are we truly alone in the universe? In the quest to find an answer, a revolutionary scientific tool has been launched into orbit, the James Webb Space Telescope. This advanced piece of technology operates like an extraordinarily powerful magnifying glass, offering a level of clarity that allows us to observe the fine details of distant celestial bodies like never before. Recently, this remarkable telescope focused its attention on an intriguing target, K2-18B, a mysterious exoplanet that immediately sparked intense interest among scientists. What made this planet stand out wasn't just its distant location, it was what was found in its atmosphere. Initial observations revealed the presence of water vapor, a strong hint that conditions for life might exist. But there was more. Scientists also detected a molecule that provoked even deeper curiosity, one typically associated with biological activity on Earth. Could this be the moment when we come closer than ever to confirming the existence of life beyond our planet? K2-18b sits about 120 light-years away from Earth and is categorized as a super-Earth, or more accurately, a sub-Neptune. This means it's larger than our planet, but smaller than Neptune, a size range we don't see within our own solar system. This unusual classification presents unique challenges for scientists trying to understand the planet's characteristics. While Earth-like rocky planets and large gas giants provide useful models for study, planets like K2-18b don't have close analogs in our cosmic neighborhood, making them more difficult to decode. What makes K2-18b even more fascinating is its location within the habitable zone of its host star, a red dwarf known as K2-18. This zone is the ideal region around a star where temperatures could allow liquid water to exist. Although K2-18b orbits much closer to its star than Earth does to the Sun, just 0.18 astronomical units, which is even nearer than Mercury's orbit, the star's lower heat output helps maintain conditions that aren't fatally extreme. A full year on K2-18b due to this tight orbit lasts only 13 Earth days. Surprisingly, this close distance doesn't cause the planet to be scorched, thanks to the cooler nature of its red dwarf star. This closeness has turned out to be beneficial. It allowed astronomers to detect water vapor in K2-18b's atmosphere, discovery that fueled speculation about the planet's ability to support life. Even more compelling was the detection of methane, a gas that breaks down quickly when exposed to radiation. Its presence suggests it is being replenished, possibly by biological processes. Additionally, carbon dioxide, another common atmospheric component, was found. But what truly caught scientists' attention was a rarer molecule. Dimethyl sulfide, or DMS, is particularly intriguing because, on Earth, it's produced almost exclusively by life, specifically by microorganisms in ocean environments. Its detection, even in small amounts, could represent one of the most compelling indicators of potential life beyond Earth. What makes this even more surprising is that K2-18b orbits a red dwarf star, which typically emits harsh radiation that is generally considered hostile to life. Yet this planet challenges that assumption by offering conditions that, despite expectations, might still be favorable. If K2-18b has a stable atmosphere, scientists believe its surface temperatures could resemble those of Earth, although with a hydrogen-rich atmosphere, its oceans might be slightly warmer. The star and planet are so closely bound that their interaction helps preserve surface water from evaporating, an important detail considering that liquid water is essential for life as we know it. This leads to the possibility that K2-18b, like other planets in its class, might have vast oceans covering much of its surface. Back in 2021, a new hypothesis was proposed by Professor Niku Madhusudan, who suggested the existence of a previously unclassified type of planet, Hyanic worlds. Named to reflect their unknown water-rich nature, these planets are believed to be enveloped in thick hydrogen-rich atmospheres and could hold deep oceans underneath. Though these worlds could be as much as 10 times more massive than Earth, and twice its size, they wouldn't necessarily be hellish or uninhabitable. Even with temperatures possibly reaching 200 degrees, the thick atmospheric pressure could allow for the presence of liquid water and potentially primitive life forms. Unlike Earth, these planets don't need to sit in a narrow range of distances from their stars to host water. Their thick atmospheres trap heat so effectively that liquid water could exist over a much broader range of orbits. And because subneptunes like K2-18B are relatively common and larger in size, they are easier to spot from long distances, making them prime candidates in the search for life beyond Earth. Professor Madhusudan and his team are leveraging the power of the James Webb Space Telescope to observe K2-18B in even greater detail. Despite the telescope's incredible capabilities, detecting ocean-covered exoplanets remains a delicate task. Observing K2-18B requires extremely precise scheduling, 5 hours of observation split into 2 sessions during a specific astronomical alignment known as a transit. This happens when the planet passes in front of its star from our perspective, allowing scientists to examine starlight that filters through the planet's atmosphere. This transit technique is a cornerstone of exoplanet research. When light from the star passes through the planet's atmosphere, it carries with it a distinct spectral fingerprint, revealing what the atmosphere is made of. By splitting this light into its component wavelengths, like how a prism separates white light into a rainbow, scientists can identify missing wavelengths. These gaps tell researchers which molecules are present in the atmosphere, offering a peek into the composition and possible conditions on the planet. Understanding these chemical fingerprints allows us to build a picture of what these distant worlds are like and brings us closer to answering the age-old question, are we alone?